Hello students, welcome back to my channel. So today's this particular video is going to be the last video or the last session for this particular lesson, which is data structure. Okay, all this while we have learned various types of data structure. Today we are going to see the very simple ones. Those are trees and graphs. So we are not going to learn them in detail. We are just going to briefly see what are they exactly. Okay, so let us start. So non-linear data structure. So what is this non-linear data structure? All this while we were learning about linear data structure. A non-linear data structure is a data structure in which data item is connected to several other data items so that a given data item has a possibility to reach one or more data item. So what is the meaning of that? So if I am to consider the array, okay, what is going to happen here? We know that this particular data item cannot reach this one, isn't it? It has to, in the way we going to reach each one of them is in an ordered fashion. But in non-linear data structure, we are going to have a different kind of a situation here where one particular data items are connected to two or more, and there are different ways in which one particular data item can reach the other. Okay, so that is what this particular statement means. Next, the data items in a nonlinear data structure represent hierarchical relationship. So when we say hierarchical is nothing but there is going to be a steps, isn't it? So as you can see, we are going to have a different levels. So this kind of a structure is called as hierarchical relationship. Now each data item is called as a node. So in nonlinear data structure, we are going to call them as node. Examples of nonlinear data structures are graphs and trees. Okay. So let us see briefly each one of them. So the very first one is going to be the trees. So before that, let us see what are the pros and cons of this particular kind of data structures. So what are the uses? Uses memory efficiently as contiguous memory is not required for allocating data items, which is very true, isn't it? When we talk about arrays, especially, because we are going to implement even the stacks using array, we are going to have contiguous memory allocation, or a continuous memory is required if at all I am going to declare an array. So without that, it is not possible. I can't have a data item here and a data item here. So that is the one of the advantage here, because we don't need a contiguous memory allocation in the case of nonlinear data structure. Now, the length of the data items is not necessary to be known prior to the allocation. This is nothing but we don't have to declare it. It need not be fixed. So that is what is one another advantage of this particular data structure. Next, what is the disadvantage? Overhead of the link to the next data item. So every time we are going to, suppose if I'm talking about a tree, every time there is going to be a link. So this overhead of the link to the next data items, that is going to be a little bit of a problematic area in this particular data structure. Okay. So first let us go ahead and see what does a tree mean. Now tree, as you can see, looks something like this. A tree is a data structure consisting of nodes organized as hierarchy. So as you can see, we have a node here, we have a node here, node here. It is all connected something like this. It looks like a hierarchy. We have a level here, we have a level here, level here, level here, isn't it? So see this image carefully. The very first node from there where all the other nodes generate, that very first node is called as root node always. Okay. And since this is a tree, these trees like this one, these are all called as sub trees. Okay. Under a tree, we are going to have smaller sub trees. Now, under this, we always call this, apart from a root node, this is also a parent node, because we call this particular node as a child of this one. Okay, so in this case, let me clear this. So in this case, this is the child node of this particular node. Okay, so this becomes a parent node. Similarly, this one is a child node of this parent. Okay, so that is how it is going to go. These are going to be the child node. And a node which doesn't have a child further, like for example, this node, these nodes, they don't have any more children, isn't it? They don't have something like this. So these are called as leaf node. Okay, so this is how a normally root looks like. And from a single parent, if they have two nodes, so then this and this one is called as siblings. Okay, so in this case, this particular case, these three are siblings, and this is the parent node of this particular nodes, right? So let us see the terminologies one by one, little briefly. So very first one is, what is a node? A node is a structure which may contain a value, a condition, or represent a separate data structure. So we saw a tree something like this, isn't it? So this particular node can be a value also, it can be a condition also, and it can be a separate data structure on its own also. Okay. So each node in a tree has 0 or more child nodes. So if this is a node, this is called as a child node, which are below it in the tree. By convention, trees are drawn growing downwards. Okay, so a node that has a child is called as a parent node. So in this case, this is going to be the parent node, and nodes that do not have any child are called as leaf nodes. So in this case, they don't have further. Suppose this one has a child, so this is not a leaf node. This one becomes a leaf node. Similarly, this is a leaf node. Okay. So the height of a node is the length of the longest downward path to the leaf from that node. So if I'm saying what is the height of this node, then what is the this is the last leaf node attached to this one. So this is going to be 1. So that is what is the height of this particular node I'm talking about. The height of the root is the height of the tree. So if at all I'm talking about the height of this particular node, then since this is a root, since this is my root node, this is also going to be the height of the tree. So in this case, the height of this one is 1 and 2. So this 2 is going to be the height of this particular tree. Okay, I hope these are clear. So next we have the depth of the node. So what is the meaning of depth of a node? It is the length of the path to its root. That is, the topmost node is called in a tree is called as a root node, like I said. So being the topmost node, the root node will not have any parents. It is a node at which the operations on the tree commonly begin. All the other nodes can be reached from it by following the edges of the link. So it is like an ancestor of all the nodes. So that is the root node. It doesn't have any parent. That is the only node which will not have any parent. Okay. So the internal node or inner node is any node of a tree that has a child node and is thus not a leaf node. So any node which has a child node is called as an internal node. A subtree of a tree T is a tree consisting of a node in T and all of its descendants in its tree. So suppose this is my tree. Okay. So in that case, this is called as a subtree, right? So these are the various terminologies which we normally come across about tree. Now let us see what is a binary tree. In the trees also we are going to have various types of trees. So we in our session or in our syllabus we are going to look up only at the binary tree. So what is this binary tree? It is the simplest form of a tree is a binary tree. A binary tree is a tree in which each node has at most 2 descendants. A node can have just one, but it can't have more than 2. Okay, so it is very clear what they are saying is, if at all there is a node, it can have only 2. So you cannot have a tree like this. This is not a binary tree, but this one is allowed. You can have one. So as you can see here, it has only one child, but having more than 2 child is not allowed in a binary tree. So our binary tree consists of a node called as a root node and left and right subtrees. Okay, so this is my root node and this is a subtree which is called as my left subtree and this is my right subtree. Okay, similarly for this root also there is left subtree, right subtree, and for this root also there is left subtree and right subtree and so on. Okay, both the subtrees are themselves binary trees, obviously, because since it's entirely all the tree is or all the nodes are following the rules of a binary tree, that is they cannot have more than 2 children. The subtrees are also a binary tree, right? So this is all about binary tree. Next, let's see some terminologies related to the binary tree. So root node at the top of a tree, the one from which all the operations on the tree commence. The root node may exist in a null tree with no nodes in it, or have 0, 1, 2 children in a binary tree. Okay, so a single root node, this is also a tree, and this is also a valid binary tree is what they are saying. So it can have 0 children. So this one doesn't have any children. This is also a valid binary tree. This is also a valid binary tree. Leaf node. The node at the bottom of the tree, farthest from the root, leaf nodes have no children. Okay. A complete tree. What is a complete tree? Tree in which each leaf is at the same distance from the root. That is, all the nodes have the maximum 2 subtrees. So this is a complete tree, isn't it? Now, next, height. What is a height? Number of nodes which must be traversed from the root to reach a leaf of a tree. Okay, so in this case, it is 1. The height of the tree is 1, right? So these are the various terminologies we come across about the binary tree. Next, we are going to see what is a graph. What is a graph? A graph is a collection of nodes called as vertices, and the connection between them is called as edges. Okay, see the difference between the tree and graph. So graph looks something like this. So we are going to have vertices. These are not called as nodes, these are called as vertices, and the link which connects them is called as edges, right? So in graphs we can have two types. One is undirected graph, another one is a directed graph. Now what is an undirected graph? First let's see what is a directed. When the edges in a graph have a direction, so something like this, when there is a direction here, the graph is called as directed graph or digraph. The edges are called as directed edges or arcs. Okay, sometimes these arrows can be something like this also, both the sides. So they called as bidirectional graphs. Now, the another type is undirected graph, which looks something like this, okay, where the edges do not have any direction. So these are called as undirected graph, as simple as that. The edges do not have any direction. Such graphs are called as undirected graphs. So these are the two varieties of the graphs. So that's all in today's session, students. With this, we have come to the end of this particular lesson, which is the data structure. It's a quite huge lesson. And also, please make a note that this is the lesson which fetches the maximum number of amount in case of your final year. So this one actually gives 14 marks out of the entire lessons, apart from what you have other lessons. Okay, so this one comes for 14 marks, which includes one 1-mark question, one 3 marks question, and 2 5 marks questions. Okay, so these questions come from this particular lesson, so you have to be thorough about this particular lesson. Very, very important. Okay, so with this, I'm going to end this data structure lesson. Hope this is helping you all in your preparation. All the best for your studies. So thanks for watching. Take care.